Okay, MAP4C day 47, second day on exponential models, and have short lesson and another activity today. So I'm stealing some more of your time away from you, but that should be okay. The 3-minute review is actually a question from the textbook, and a neat sort of question where we've got a formula of some sort, and we're asked to, pick some numbers so that whatever we're left over with is a linear function or a quadratic function or an exponential function, depending on what we choose. Remember, linear function, there's no, it's usually y equals mx plus b, but we got no plus anything there, so forget about that part. So what we want is to have a number and then only an x value. So for instance, pick, and I'm just picking these. So I'm picking these so that the thing that I end up with ends up being a linear function. Okay, so I'm going to pick n to be known. Let's say n is 2. Pick r is maybe, and I'm just picking these, r is 3, and then I'm going to leave b, and I'm going to leave c. So what does the formula become? It becomes c equals b times 1 over 2 to the exponent 3, and 1 over 2 to the exponent 3 is 1/2 times 1/2 times 1/2 is 1/8. So then that function is b times 1/8, or 1/8b, where then b is my unknown. That's kind of like my x, and my slope is 1/8. It's kind of like that. It's linear. And if I were to put that equation into a graphing calculator, I'd see that it's linear. For a quadratic function, we want it to look something like this, right? And again, there's no other parts, so obviously, or should be, that the r value has to be 2 to have a quadratic function. So I'm going to have the r value is 2. I'm going to pick the b value to be anything that I like. I'm going to pick it to be 100 people at the start of the tournament, and then I'm going to leave n. So then what is n c again? C is kind of like my y, and it's always going to be left. So I'm going to, b is 100, n is left alone, and now I'm r is 2. See how this is the unknown. So this is kind of like y equals 100x squared, where this is the unknown. This is quadratic. And then exponential function, we know in exponential functions, the exponent is unknown. That's where the x goes. So if I pick n is something and b is something, then I'll be left with 100 times 1/2 to the exponent r. And that's kind of like y equals 100 1/2 to the exponent x, right, which is an exponential function. And again, it's a decay function, right, exponential decay function. And if we wanted to put those in a graphing calculator, we would indeed see that these are a quadratic function in b and an exponential function in c. Exponential models, day 2. One short example here, and then into the activity. We've got some data, and the year is the number of years from 2002. This is the index value here. 2002 is 100. Wasn't included on your sheet, but you can figure that out. All we have to do is put this data into a graphing calculator, and instead of quadratic regression, which we did the other day, linear regression before that, we're going to do exponential regression. It looks like, I mean, the initial value should be 100, and so hopefully that works out. We'll see that maybe it's not exact, but you get your graphing calculator going. I got old data in there, obviously. So if you've got old data in there, you got to go up and clear it out. Remember, clear, enter, clear, enter, and then put the data in. And this is years from so this would be 2002, that's 2003, and so on. I'm going to pause the video and put the data in. You can do the same thing. All right, I got my data in there. I'm ready to do regression. Remember, regression, you go stat over to calc, zoom past linear regression. We're going to zoom past quadratic regression and go to exponential regression. So exponential regression. And then I'm going to press enter. And then I can see my function there. I'm going to just copy this. It's easier for me to do that. And so the function then is y equals 98.8 if I rounded, and then the b value is 1.03233 maybe. I'll go 2.5. Why not? And then to the exponent x. So I see my initial value was 98.8. It was a little different than I expected. I expected it to be 100. And then I see this is a growth, exponential growth, right, of 3%, right? The R value is 0.0325 or 3.25% growth, if I wanted to see that. That's done. Use your model to predict the CPI for 2020. 2020, how many years since 2002? That would be 18 years since 2002. So I just jam this into a calculator. I'll put that, I'm going to use my graphing calculator maybe. 98.8, 8.8. To the exponent 18. It's going to be 175. And change. What was the change? So what does that actually mean? Remember, for an index, it's always a comparison. It would mean in those 20 years, farm input CPI, this is cost to farmers to do their business, has went up by 75% since 2002. By 2020, that's what that means. Okay, a little word before you get into the homework about the activity I want you to do. There's a handout in your package called Comparing Regression Models. You need to find two partners, and hopefully that'll work out. Partner 1 is going to do a linear model, and partner 2 is going to do a quadratic model, and partner 3 is going to do an exponential model. And essentially, you just follow the instructions for those for that model. So if you're doing quadratic model, you'd write in quadratic here, your partner 2, and then you go through the exercise as if you're going to model it with a quadratic. And this is actually the last thing we're talking about in this unit is, you know, deciding is a situation linear, quadratic, or exponential. Okay, so you can do that. Homework is on the TI-83, and the activity is with two partners.